Hello there. How are you doing this morning? Hopefully you are a little bit more addicted to technology this morning over the last couple of days. You know, we have had 2 great days. And hopefully you have also made some good connections and met some interesting people. We have another great day planned for you today. You know, last year I attended an event hosted by GE CEO Jeffrey Milt. And at this event, he said, GE is now a software company. In fact, he said, every company right now has to become a software company in order to survive. You know, yesterday, obviously, we heard Peter Hollicky of Dow Chemical Company said, at Dow, we are addicted to technology. I would say GE is addicted to industrial internet. And GE right now is in the process of implementing, rolling out industrial internet at their plants as aggressively as they can. To hear more about this, please join me welcoming Stephan.Biller, Chief Scientist at GE Research.
Good morning. Thank you. Thank you all. It's a pleasure to be with you this morning. As Andy said, so when you talk to our CEO, he talks about, a few things, but mostly he talks about innovation. And so for me, as a guy who's interested in innovation and research, that's great. The next thing he talks about is advanced manufacturing and how we're going to have to lead in advanced manufacturing. And I'm thinking, you couldn't be at a better spot at this time. Your CEO, not only is he interested in innovation in general, he's also interested in manufacturing. I think I've never seen that before. So I'm very fortunate to be in that spot. And this morning, what I would like to share with you is our vision on Brilliant Factory. And I want to accomplish 3 things this morning. One is to introduce that concept. Many of you will say, "Oh, I've seen this." So I just had a chat with our German colleagues who will join us in the panel, and they say, "Oh, this is just Industry 4.0," and other people call it different things. The Internet of Things, the Industrial Internet, the Brilliant Factory, asset performance management. And I think we all agreed, let's just do it. I don't care what we call it, let's just do it. So let's talk about that concept. The second thing I want to talk about is the concept of open innovation, which we're exploring, which is sort of new, and I think it's very exciting, and it's in the end will be enabled by a concept like the Brilliant Factory. And the third thing I want to talk about is a new business model for innovation that we are starting to explore with one of these National Institutes for Manufacturing in Chicago on how we're going to improve the speed of innovation. And this is clearly experimental, and you'll be the judge if it holds any water, but I'll show it to you. So let me just talk briefly about GE. GE is changing a lot. We used to have about 70% of the company was driven by GE Capital. Jeff Immel is changing that. With the Alstom acquisition, I think we'll be roughly 25% industrial, 25% capital, 75% industrial. And here's the breakdown. The big 4 for us are healthcare, aviation, power and water, and oil and gas. Oil and gas, even though the oil price is shrinking right now, it's probably the division that is growing the most in General Electric. And we really started building that with our acquisition of Nuova Pignoni in Italy in the 90s. So something we are very proud of. We have grown that from $1 billion in revenue to, I think it says 15 here, but there are more acquisitions to come and more organic growth to come. So we think that's going to grow a lot more. And it's 50,000 technologists working for General Electric out of 300,000. It's a technology company, and we are very proud of it. We spend about $5 billion on innovation in General Electric, and 10% of so is spent in core research. In fact, during the 2008 downturn, Immelt actually doubled down on that. It was roughly half that, and he said, he sort of goes anti-cyclical. When things are tough, that's when he thinks he should invest. So I wouldn't be surprised if he does anything in oil and gas, where times are tough right now. What's the advanced manufacturing potential within GE? So we are making and purchasing about $72 billion in manufacturing. We have 400 factories. We think, these initiatives in Brilliant Factory will help us to get two times faster in product development. The auto industry has shown us how to do it. I think we want to copy that. And we think we can go 30% lower cost through all the real-time data. We're collecting the plants, increasing uptime of machines, improving manufacturing systems throughput, supply chain efficiencies, etc. So why is it? What are the trends here? It's really the, and I don't have to tell this crowd, but when I talk anywhere else, it's the how are we merging the industrial internet with the hardware? It's hardware meets software. That's really what's driving it here. And on the advanced manufacturing side, at GE still being a major materials company, it's really integrating manufacturing innovation, design innovation, and materials innovation. And how do we make that not a sequential, but a concurrent engineering effort? On the software side, as you heard, maybe we have a new software center in San Ramon in California with more than 1,000 people. This morning we had a breakfast with our GE Intelligent Platforms group. They are changing their strategy from selling software to selling solutions. It's really about integrating the domain knowledge we have with the software knowledge we are building, and doing that on a platform in the cloud, and with all the IT opportunities the world is practically giving us right now. So it's really meeting physical and digital. They are converging. If you think about the hardware piece, we used to just put all of our new processes into our factories. Today, if you want to have that approved, you have to have a data integration strategy that says, okay, don't tell me all the stuff what you're making with these P&E investments. Also tell me what's your data strategy. How do you integrate that into our Predix platform? How do you integrate the data streams into the manufacturing processes? How are you going to use those data to improve the processes? And how are you going to use those data to improve throughput and supply chain efficiencies? It's also agile. So we're moving into a world where we don't have dedicated factories anymore. The factories we are building today, some of them are what we call multimodal. So we are putting in factories that can work in the aviation space, in the power and water space, potentially in the healthcare space. Why are we doing that? Well, to buffer against demand uncertainty, which seems to grow by the day. And then finally, we think there are new ecosystems. And this was driven, I think, by additive manufacturing. If you think about additive manufacturing, it's really a cool technology, but it creates this ecosystem. It creates an ecosystem of lots and lots of tinkerers and people who just want to do this. They might not even have a formal education, and they can create a design. They can have it printed somewhere, and they can sort of make a product in a very small shop. So it democratizes manufacturing to a degree we have never seen. And on that note, so we are pursuing, this is the first nugget I really want to give you, and I want you to think about whether that's something you want to pursue. We're going after these open innovations. So here's an example in the advanced in the additive manufacturing space. You see a bracket here. It's a simple bracket from our aviation business. It's not strategic. What we wanted to do here is we wanted to test out how is this open innovation model working? Is it working for us? Should we try more? And what we did is we put this out there. We put out this bracket, and we said, we want to reduce the amount of weight in this bracket, and you have to make it additively. And we thought, and we put a price out there, I think $10,000 or so, a pretty small price money. And we thought, well, maybe we get 20 or 30 entrances. We got almost 700 that passed the engineering validation. 700 people who were willing to work essentially for free, going after what I would consider a fairly small price, and giving us designs for free. That's amazing. That's a new model that we certainly had never thought of before 5 years ago. And it allows you to not only have like maybe a staff of a couple thousand people in your research division or tens of thousands of people in your engineering division. It allows you to reach millions of people who can be part of your innovation ecosystem. And that's really amazing. So the winner of this contest came from Indonesia. He had very little formal engineering education, and he reduced the weight of that bracket by about 85%. To me, that's an amazing outcome. And I think you might want to think about within your business, is that something that's of interest to you? We used a company called GrabCAD that hosted that for us, so we didn't have to build any of the infrastructure. There are many of these companies who do that. Go out and look and see if that's something you want to pursue as well. Now let me talk about the brilliant factory concept. So if you think of the 20th century, there are really two major paradigm shifts. Everybody in this room knows that. The moving assembly line and lean from Ford and lean from Toyota. But we think, we can build these brilliant factories. And what are the elements of that brilliant factory? So let me walk you through this. We think that's the next paradigm shift. I think most of us will agree that the components are all there. It's a question of putting it together. So let's look at that little schematic here. It really all starts with design. We all use PLMs to design our products, CAD models. We test the performance through thermal simulations, all sorts of simulations going on to figure out, is this going to help me achieve the performance I want to get? The auto industry, I think they used to run like 300 crash tests. Today they run 5 because they do most of their crash testing in virtual. The only reason they run 5 is because NHTSA, the regulator in Washington, D.C., makes them do it. They really don't have to do that. Reduces the time enormously. The next thing on that schematic is the virtual manufacturing piece. How can we start up our factories in virtual? How can we do controlled simulation, robot simulation, throughput simulations, any type of process simulation, forming, joining, you name it. How can we make everything virtual? And we're doing most of that right now. What we don't do is we don't integrate these things well. There's a change. I'm never sure whether all the simulations are updated. Are the people really working with the newest release from design? Not very clear. That's critical to establish. Once you have established that factory in math or in virtual, if you wish, now you move to the real factory, and we are basically getting, gigabytes and terabytes of data from our robot controllers, from from the PLCs, from the MESs, from the ERPs. There are roughly about 20, 30 systems in every factory, IT systems, some of them legacy. They don't talk to each other. At least they don't talk to each other well. If some of you went to our presentation this morning, GE Intelligent Platforms, we are now moving to an environment where we integrate all those data streams through a platform we are developing with our new software COE called Predix, and that we think will allow us to integrate all the data and make decisions and understand trade-offs. Because the easiest thing for anybody who's running a factory, and maybe they are responsible for the energy management, if I wanted to get optimum energy, I'd turn the factory off, make no product, and I'm at 0, but that might not be so good for my throughput. So it's really all about how do we get these trade-offs visualized? How do we get this trade-off after we visualize it? How do we control? And then how do we optimize? And so running the factory at, let's say, an optimal control point, if you're a controls engineer, that's really what we're after in the brilliant factory piece. And of course, you need to integrate your supplier into this, into the design, into the virtual manufacturing, and also, of course, into the production, because you can only make your stuff usually if you have all the parts. So in the end, it's all about allocating resources in real time, and resources being equipment, people, and parts, and making that factory as productive as possible. Now, let me extend this to a third area, and that's where I think this is a little bit unique compared to the other visions, which is the service piece. GE services a lot of its major product. 80 or 90% of our customers who buy a jet engine from us today, they buy a service contract with that. And not only do they buy the service contract, they put all the risk back on General Electric. So they pay us a fixed amount of money and we guarantee a fixed amount of uptime of their, let's say, jet engines. And we do the same in oil and gas, we do the same in power and water. It's a business model that works for us and it works for our customers. So every time we open up a jet engine, we have an opportunity to see what went wrong with that jet engine. And right now, we are not taking enough advantage of those data. We're repairing it, we're putting it back into service, but really what we want to do is we want to think about a product that is constantly improving. And it's constantly improving based on how did I design it, how did I manufacture it, how did the customer use it, and what do I see in the service records. Feeding that data back to design allows us to get to a product that continuously improves. On the factory side, that's a production feedback loop on top there. We basically have to think about what if something goes wrong within the factory? What if a robot goes down? How are we going to address that? And just think about you have a cell of 5 robots. Let's say your predictive algorithms, based on all the data you're collecting from those robots, tells you robot number 3 is going to go down in 10 minutes. How do you reallocate the work? I think what you want to do is you want to get back to your virtual model, validate that the change you're going to make is safe, download the change to the factory, and do the work with 4 robots. Slowing down maybe a little bit, but potentially getting to a factory that never stops. So factory that never stops, product that continuously improves, basically based all on the digital integration of design, manufacturing, and service. That's the concept when we talk about Brilliant Factory. And we've made a lot of progress in that. So we've done a lot of process modeling. We have like better models for casting, helping us open up design spaces. We have producibility tools that tell the people in design ahead of time, can you make this product in this particular material? Can you get this to this radius? And what is it going to cost? So we integrate should costs computations into that. And not only that, we'll say if you just loosen up that tolerance a little bit, you don't have only one supplier, you might have 3 suppliers that can help you make that. Everything is becoming model-based. We're trying to get away from paper. We're not there yet. We're pretty far away from that, but that's where we're going to go. I think I said the auto guys have shown us how to do it. I think we at General Electric we're going to go that same path. We might be able to go a little bit faster, but it's also a little bit different because automotive, high volume, low margin, we are just the opposite. So we have to adapt that model to that particular environment. Furthermore, on the factory, if you look at that, how do you get to understanding to use your machines better? How do you get to asset performance management, managing your machines based on the data you're getting? I think there's a session on MT Connect today. Lots of people try to get the data out. That's the first step. Next step is what I'm going to do with the data. And the third step, how am I going to optimize the machines based on those data? So to me, it's always first see, then control with a human in the loop, eventually go to let's optimize it and automate it. We also need to look at the systems in the factory. We have done that. We have done manufacturing simulations for a long time when we do layouts. Well, we need to get to an environment where we can use the real-time data to identify those bottlenecks in real time, because those bottlenecks are shifting all the time. We need to figure out how can we update the schedule based on that, Harry and Joe are sick, or I'm not getting a part from supplier B, or that machine will be down for 10 hours. How do I operate that factory at the optimal control point, given all the input from all the data? It's going to be complicated, and we're going to need advanced math to do that. We have to think about risk analysis. So as we are laying these factories out, and I told you about the multimodal piece, how much capacity do we really need? It appears that we could probably get by with less P&E if we understood the risk better especially if you have businesses that are counter-cyclical. So right now, as you know, the oil industry is down. That means our revenue in oil is probably going to go down. Aviation, on the other hand, is carrying the business right now with power and water. So we have businesses that are, that when one is down, the other one is up. That works pretty well for GE. We have to think about how we're going to take advantage more of that in the manufacturing side. In the end, we have to think about manufacturing and supply chain as a system. Most of you have done that for a very long time. The move, I think, is from, let's not only do it in planning, let's do it for real time, for using the real-time data we are having. Here's some examples of that. So, we are networking in our power and water business. We are networking with Clear Sky. Some of you are using that probably. How are we using 40-year-old machines? How do we get the data out? How do we integrate that with a cell controller? And you see here, we get like 10, 20% more uptime, better quality. We're using analytic optimization to improve inventory performance, to improve capacity utilization. You see the numbers here. They can be staggering. And if you think about what that would mean in terms of P&E savings, that's a lot of money in your pocket you want to save. How are we going to get there? Well, first of all, we need a system, an ecosystem that works together. We need the SMEs, the small, medium enterprises. We need our suppliers. And we need to play with our customers. And often we are a supplier to, for example, Boeing for jet engines. We need to work together with universities, with national labs, with other industries. And we use these technologies that are listed down there. High-performance computing, I think, is a real important one. I mean, the advances we have made there, or people have made there, are mind-boggling. You can today do casting simulations you would have never been able to do, just say 2 years ago. That helps you open up the supply base, reduces your cost. It's a winner both for you and the supplier. Lastly, I want to talk about this new business model. How are we going to integrate those national labs? How do we integrate the SMEs, the universities, and so forth? And we think of this as an app store, right? The Apple App Store, we all use it. But what if there was an app store for manufacturing analytics, for manufacturing simulations? How would you lay this out? And this is only a schematic, but I think you will get the idea. So on the left side, we have the GE App Store. So we are developing our own simulations in casting, joining, whatever it may be. We're going to develop real-time bottleneck detectors. We're going to develop real-time analytics to figure out when a machine goes down. And they all will sit on this platform we are developing with our software group called Predix. Why? Because that will allow us to develop that app only once. We don't have to integrate it with different types of software. All the software we're having in the plans, be it an old quality system, GE IP, IBM Maximo, PLM, whatever it is, feeds into that platform. If you get to that platform approach, you win because you have to develop these apps only once. All you really have to do, if you get a new system that you have to integrate, you have to figure out how to integrate the data stream into that platform. Platform is the major thing for us that, in our opinion, will change manufacturing. Then, I don't know about you, but every week or two, somebody calls me and tells me, I have a new software, and it has been used by Daimler and by Siemens and by all these other companies, Thyssen, and they have saved billions of dollars using my software that I developed, and it can help you improve uptime, it can predict bottlenecks, whatever it may be. Especially great is when your CEO or a vice president of supply chain sends you that and say, have you seen this? They can do all this. What do you think? It's very, very hard for me to evaluate that. Why? Because I have to find a factory who's willing to do it. I have to get people who are willing to do it in that factory. I have to pay the integration cost of that, and I have to figure out what data do I have to feed this with. So I'm really not taking advantage of all the innovation that is given to me. So here's an idea of how we can overcome that. On the right side, there's something called the DMC that stands for Digital Manufacturing Commons. It's something we are developing with many other companies through this National Manufacturing Institute we are standing up in Chicago called the DMDII. It's a mouthful, and it stands for Digital Manufacturing and Design Innovation Institute. It's one of these 15 national centers for manufacturing the president wants to stand up. This has gotten the funding. It's just getting started. The idea is really to develop a platform there and to put my data, my old data, 5-year-old design data, 5-year-old factory data, data that is not proprietary anymore, out there and say, if somebody comes and says, can I test, I have this new software and it helps you improve predictivity of when machines are going to go down. What I would want to tell that supplier, go there, show it to me, so the supplier has to pay the integration cost. It's good for the supplier because not only it's General Electric, it's like 50 other companies are there and we think it's going to grow. So they can demonstrate by integrating into that DMC what their particular software can do. Once they've demonstrated it and I'm convinced that that's a good thing, I can now connect this through this gray arrow there to my internal platform. I run the software with my proprietary data and I see if it holds up. Is it still true? And if so, I can basically get the external app into the internal app store. The integration cost is already paid for. I've demonstrated the benefit. It will be so much faster both for the supplier and for the OEM to improve their speed of innovation. It's only an idea right now, but I think it will be an important idea for the future, and these platforms are making that happen. So, as I said, it's in Chicago. So, to summarize, brilliant factory, interconnected, automated, never surprised, factories that never stop. We have all the ingredients. It's exciting. I don't think there's a more exciting time for all of you who are in this space. I haven't seen such excitement in General Electric for manufacturing ever. So for us, it's great. I think it's great for you. I'm looking forward to the discussion, and I think Andy's going to ask us all the questions. So thank you so much for listening this morning. It was great to be with you. Thank you.